Assalamualaikum. I am Muhammad Ismail Hussain, BSCC 1433. In this video, we are going to explore the solid principles of object-oriented programming. These 5 principles will help you write cleaner, more maintainable code. For each principle, I will first explain the concept and then walk you through a sample code example. So let's start it. These 5 essential design principles is useful to understand the code easily, maintain the code efficiently. So these 5 principles are single responsibility principle, open closed principle, Liskov substitutions principle, interface segregation principle, dependency inversion principle. So first of all, single responsibility principle. If a class is handling multiple responsibilities, it can quickly become complicated and hard to debug. So for this, in this bad example, the report class is responsible for both generating a report and printing it. If either the generation or printing logic needs to change, you have to modify this class, which increases the risk and complexity. So in the good example, we have separated the logic into 2 different classes, one for generating and another for printing. This makes the code more organized and easier to change in future. Open closed principle. This principle says your classes should be open for extension but closed for modification. That means you should be able to add new features without changing existing code. In our which makes code easier to maintain and reduces the risk of bugs. So in our bad example, the area calculator checks the type of each shape. So every time we add a new shape, we have to go back and update this class. This quickly becomes messy. In the improved version, each shape class knows how to calculate its own area. If we want to add a new shape, we just create a new class. No need to touch the previous class of the area calculator. This makes our code more flexible and easier to maintain. So then Liskov substitution principle. This one can sound a little abstract, but it's really about making sure the subclasses behave in a way that's consistent with their parent classes. In the bad example, we can see we have a rectangle class and a square class that extends it, but the square class changes how width and height work, which can lead to unexpected bugs if we treat a square as a rectangle. To fix this, we should separate the 2 classes and have them both implement a common interface. This way we can use the interchangeably without worrying about hidden superclass. Interface segregation principle. It says that it's better to have many small specific interfaces than one large interface. This avoids forcing classes to implement methods they don't need. In the bad example, we have a single worker interface that requires both work and eat methods. That means even robots which don't eat have to implement an unnecessary method. A better way is to split the interface into workable and eatable. Now each class only implements the functionality it actually needs, making our code cleaner and more adaptable. Dependency inversion principle. This principle says that high-level classes shouldn't depend directly on low-level classes. Instead, both should depend on abstractions. This principle reduces coupling between system components. It facilitates easier testing and maintenance. In our bad example, the switch class is tightly coupled to the light bulb class. If we want to use the switch for another device, we have to rewrite the code. But if we introduce an interface that's called switchable, both the switch and any device can work through this abstraction. Now our switch can control anything that implements switchable, making our code much more flexible and reusable. So that's all about the introduction to the solid principle. By following these 5 guidelines, we will find your